Hello, Professor.
Yes, I'm here.
Hi, good afternoon. So I think we can get started our class.
Okay, thank you.
Okay, okay, thank you.
Okay, so following the lecture in the morning, we will continue our lecture uh, based on some techniques in data analysis. So in the morning, we cover some basic commands in R, especially for plotting and some packages like Explorer for uh, data analysis. Uh, like I mentioned, there are a bunch of packages that can help us to do data analysis easily, so that we don't have to write every line of codes by ourselves, because those packages can help us to save a lot of time in coding, especially for some of you who are really new to this R interface or R language. I know some of you are learning Python right now, but maybe you will get confused with these two languages. But basically, these two languages are uh, are made for specific purpose. Uh, but in R, most of our users are more statistically oriented. So if you are a researcher or if you are a statistician, you probably will like to use R more than using Python. But Python now is becoming more and more popular. So I will also suggest you to learn Python at the same time. But in some uh, in some ways, in some dimensions, I mean, R enjoys some advantage over Python. But of course, if you are interested in text mining, uh, data analysis, I think maybe Python enjoys more advantage over R. But I think both languages are all powerful in handling the machine learning and the AI techniques. So I don't think that will be a big problem. But most important is that the R has been developed by many users uh, on new packages. So as new packages are generated each year, I think R will be more conveniently uh, used by more people. I think that's one advantage. So let's jump a little bit further. Let me just share my screen here. Just a minute. I'm gonna share my screen. Just a minute. Well, I need to find my, I just get lost. Okay. Just a minute. Okay, so okay, now you can see my screen. Like I mentioned, we cover some pieces of code. In the morning, we cover R01_3, R01_4, and now we're gonna cover R01_7. You can find those files and from my GitHub. Actually, I have uploaded. I have backed up both those files in my GitHub, so you can just find my GitHub website and then download those files directly. Of course, some files, some piece of codes are skipped because of time constraint. But I just want to focus on the most important part. Yes, like I mentioned, I'm gonna describe some basic plotting functions in R, especially by ggplot2 package. I think that's important for you to know. And this topic will cover some data processing approaches. Okay, so let's start from the first one. We have some basic commands here so that you have to know. So we have the first one, which is split. Okay, split basically is to divide the data in a vector X into groups defined by F. Okay, so the replacement forms replace values corresponding to such a division, and unsplit reverses the effect of split. So let's say, let's take empty cars, for example. We have empty cars already. I believe all of you should know the empty cars dataset already. It's because we mentioned that in the morning. And let's say, let's just split the cars, empty cars, by cylinder. Okay. So basically the function is very straightforward. The first one is empty cars, and the second one is empty $ by cylinder. Okay. If you have already loaded up the tidyverse, you can also use this command like this, empty cars. We just use pipeline, okay, pipeline to empty cars, or even you can just type cycle, okay, and we just yeah, you can even use this command because probably this can save you some time in the typing, okay, because yeah, let's try it. Okay, so you can see that actually the dot is the short name for empty cars, so we just use dot cy dollar sign cyl. So now you can see the data is being split into 3 lists. Okay. So now you can see the result is created. Let's check this class of GR anti-cars. Oh, sorry. Okay, so now you can see the anti-cars originally is a data frame, okay, but after we run the split function, the the data frame has been converted into list. Okay, so list is a big table. You can just assume that to be a big table, but the table has, within the table we have many sub lists, okay, or subtables. So we call this data format as list, okay. But for data frames, we can't have many subtables within data frames. So that's why we use list quite a lot. Especially in this case, now we just split our files, our data set into different subdatas or sublist or subtables. So that's why we have a list like this, okay? And if we check the structure of the list, okay, so now I'm gonna use str. Str means structure. So I'm trying to use structure to see what's inside there. So it shows that we have 3 lists of about the data. And list 1 is 4. The name of the list is 4. Okay. The second list is 6. 6 is the name of the list. Okay. 4, 6, and 8 are the name of the list. Okay. And we have a data frame for list 4. We have 11 observations or 11 variables. Okay. For sublist 6, we have 7 observations of 11 variables. We have sublist 8, we have 14 observation, 11 variables. So that's why we have 3 lists. Okay. So to access the sublist, we can just type gr.ntcars, and we use double square bracket, and we can just use, I remember, if I'm not sure about that. Let me try if it works. Okay, it doesn't work here. Maybe I can use sublist number 1. Yeah, let me just check the structure. Okay, so now I'm trying to access the sublist number 1. Okay, so I can just check. I can just use 1 in the double square bracket so that I can access the sublist 1 and sublist 2, sublist 3 in the following. Actually, we only have 3 sublists, so now we can just use 1, 2, 3. And I want to know how to list through names. Let me check. Okay, so names of the sublist are 3, 4, 6, and 8. So I'm not sure if it works. 4. Okay, so now it works. So I can also access the list by sublist by names. So now I'm accessing sublist with the name number 4, which is number 1 sublist in GR empty cars. So that's how I can access the sublist numbers. Okay, so that's very easy for you to test those functions, and basically you can just use the structure first to see the details of the data frame of the data. Okay, so now you got a lot of data here, and then you can use list, and also you can use grimps to back to just take get a glimpse of the data. Okay. Yeah, we have the same results as we did for structure. Okay, so that's about the empty cars. So now we finished the empty cars by split. Okay, and then sometimes we need to do some calculation. For example, like we have to split and compute sublist data one by one. So now we can just use L apply. L means list apply. Okay, so we will apply this function to the sublist data of gr.mpg. So we'll get the result. Let's see what we got here. MPG. Okay, so we got gr mpg by list. So here we are. We got the mean value of mpg for cylinder 4, mean value of mpg for cylinder 6, and mean value of mpg for cylinder 8. Okay, so that's how we apply the function to individual list within the data set. Okay, yeah, we can also use s apply. Yeah, we'll get the result, but output is slightly different. Yeah, you can see now the output is not a list. Okay, see the difference between these two. The first one, when we use L apply, the result will become a list. List name, this is list name 4, list name 6, and list name 8. Okay, we got the mean MPGs for each list. And if we use S apply, then the result will be more simple. We can see the number 4, 6, and 8. We got their mean values. Okay, so this is another, this is another example. We can also provide our specific function. Okay, so for example, yeah, this is not a function, this is just specific names to filter data from state.x77. Okay, so let's take a look at state.x77, what's inside there. Okay, so now you can take a look at state.x77. That's the population, income, illiteracy, life expectancy, murder, high school graduate, I believe so. It's a frost area, whatever. So that's a graphic information across all states in United States. We start from Alabama until the Wyoming. Okay. So now we need to do some filter. So for example, like we like to spread the data according to state. Okay. Now we have a state region. Let's see what state region is. State region, we have south, west. Okay. So there are a lot of information here. So we have just a minute. What exactly we have here? Stay here. Let's take a glimpse of state 77. Nothing interesting here. Okay. So let's run it anyway. I think there should be some variables indicating north, south, and north central, west, etc. But I don't know why we don't have this information. I think probably, I don't know why we don't have this information. Okay. Maybe okay, I'll find out why we got these results later. But I believe maybe they just identify the area by the area, identify the region by area. I'm not sure about that. Okay, let's just skip it. Okay, so let's go down here to subset. I think subset is another useful function here. So right here, we're gonna use iris as our data. So now I'm trying to subset our data by some criterion. So now I'm setting sepal length greater than 5. Yeah, this is very similar to select function we've used before. So let's see, we have subset here. Yeah, okay, we got subset. Okay, so now we are filtering our data by some criterion, which is sepal length greater than 5. Okay, so you can see now we all have sepal length greater than 5 here. So that's one way to filter our data. And also you can add more criterion. So for example, like sepal length equal to 5. And within the selection, within the function, you can even define the select, okay, equals to 2 categories. One is sepal length, another is a species. So let's see what we got here. Okay, so now we got the sepal length species here. Okay. Okay, and the third one is about the R bind. R bind is row bind. C bind is column bind, and merge is to merge two data frames or tables together. So that those functions are useful. So for example, right now we just give you some basic data set. We got ID 1, 2, 3, 4, and then is ABCD, and then we create a data frame called student 1. So now we create student 1. Okay, so let's check student 1. Now we got ID and the name for student 1. And similarly, we can create a student 2. Okay. And then we try to combine this data set together. Now we're using RBind. RBind means row combine. Okay, row combine means we put student 1 on top of student 2. Okay, so we'll see what we have here. So now you can see ID number starts from 1 through 4, 5 through 7. Okay, so everything is fine here. And similarly, you can use column bind. So which means they put one column by another. So let's see, we have NANSEX and the student 1, student 2. Let me run this line by line. Student 1, we got student 1. Yeah, this is student 1. And this is student 2. We got the score and sex. Got student 2. Okay, so student 2 is score and sex. Okay, then we just column bind together. So we got this is what we got: ID, name, score, and sex. Okay, and then we have merge. Okay, merge is used quite a lot. We try to create data frame first. So this is data frame 1, df1, and df2. Okay, so let's see what we got here. So basically, we create a series of customer ID 1 through 5, and product. We got toaster for 3 times. Here we are using a useful function we call REP. REP means repeat. So that means we are repeating toaster for 3 times. And then radio repeat for 2 times. So there'll be 5 repeated values, okay? 3 for toaster and 2 for radio. So that's the product. Okay, so let's create data frame 1. And similarly, we also create data frame 2. So you can check data frame 1 here. This is data frame 1, and data frame 2 is here. But you may notice that the number rows are different. Data frame 1, we have 5 rows, customer 1 through 5. And the data frame 2, we also have customer ID, but starts from 2, 4, and 6. Okay, so both data frames share the same column, customer ID, but maybe part of them are the same, but maybe some numbers are missing. For example, like customer 6 is not in data frame 1. Okay, so let's just merge these 2 together. So the first merge is about inner join. Okay, inner join means we are choosing the intersection of df1 and df2. So that means we will merge the common part of these 2 data frames. and the key column will be customer ID. Okay. Well, this is very similar to the database, like SQL. Okay. If you have learned SQL, we are also sharing the same concepts. We are using the same concept, which is the same customer ID, okay, to access specific data. But let's see what we got here. Okay, so now you got the customer ID, 2 and 4, and we got the product, we got state. Okay, so we have the intersection part of the two data frames, which is 2 and 4. Okay. And then we are going to use full join. Okay, so that means we just combine these two data frame together by 4s. Okay, so that means we don't care about the common part. We just enforce these two data frames to be combined together, to be merged together. So we have all true, all equals true. Okay, so that means we are implementing full join. So now you can see we have customer ID 1 through 6 product, but of course for customer ID 6 we don't have any information in product, and of course for state we also don't have any information for that. We only have 2, 4, and 6. Okay, so that's about the full join, and similarly we can use left join. Okay, join by keeping X customer ID, and we can also use right join by keeping Y customer ID. So you have to specify O.X equal to X, O.Y equal to true. Okay, so let's see what we got here. This is what we got for X, and this is what we got for Y. Okay, so that's about the data joining. Yeah, of course, we do have other information. We do have other functions provided by tidyverse. Of course, you will see that in tidyverse package about the join. Probably you would like to use those functions provided by tidyverse. So for example, like left join. Okay, so let me just show you. Okay, so let's see what we have. In terms of joining, actually that's provided by dprior, which is also loaded up by tidyverse already. So you can see those functions are more straightforward to understand. So they are using inner join, left join, right join, or full join. Even more than that, we have semi-join, nest join, anti-join. Okay, but most of the time, I myself are using only left join most of the time. Okay, but it depends on the condition you have. But one thing is that if you want to use this, you have to know some specification for those arguments, for those input data, for example, like X, Y, are tables to join, okay, and then probably you have to convert the data into tables format. Okay, so sometimes you don't have to worry about that because you can find a lot of sources from the web when you are going to use this kind of functions. Okay, then we sometimes when we are processing data, we tend to have missing values. So in terms of missing values, sometimes we have to delete missing values altogether, but that probably will substantially decrease the number of observations in our data set. So maybe some people like to see a complete data set, okay, without any missing values. Sometimes the missing values can be imputed by some statistical methods. So now we're going to introduce some approaches in dealing with missing values. So first example, let's create a missing value data set. So for example, now we have a temp data set here. Yeah, this is just example. We created temp data set, and there are two missing values, which is NA, and we can use is.NA to check if there's any NA values in there. So you can see the result: false, 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 true, false, true, false. Okay, the data number 4 is true, which means there's an NA value there. Okay, 4, 5, 6. The data number 6. Yeah, we have also NA values. Okay, and how many NA values in our data? Then we can use sum to check the NA values. Okay, so actually we got the number 2. So we have 2 missing values in our data set. Okay. Okay, so let's use Iris dataset as an example. Now we're gonna use some functions by the package we call Miss Forest. Okay, missing. Yeah, this package can help us to generate missing values randomly. Okay, so now we're gonna use. So let's just load this package. Actually, this function is built by a package we call Pacman. So we can also type Pacman double colon here and followed by the function. So that means we're using Pacman, the one of the function of Pacman package, which is pload. Okay. And then we're gonna use produce NA. So this is function to produce NA in Iris. So number NA maybe 10% in our data set. So let's see. Yeah. Okay, so now you can check the data right here. Okay, now you can see the function can create random values, random NA values. Okay, you can see now we have some NA values here. NA values here. We got some NA values here, right here. Okay. Okay. Sometimes, yeah, sometimes. But actually, when we are dealing with data from the real world, almost always we will see a lot of missing values. So that's why we have to know how to deal with missing values. Okay, method 1 is to delete missing rows. Well, that's the most straightforward way to do that. One function can help us to do that. We call complete.cases. Okay, complete dot cases means we need the complete cases. That's all. Well, let's see what we got here. Okay, since we have 150 observations, so the number, the number here denotes the number of rows, and the row 1 true, row 2 true, row 3 true, row 4 is false. Okay, so this is row number 4. So let's see, let's check now row number 4 to see if there's any values. Okay, right here we got any values in that row number 4. So that means not row number 4 is not a complete case, right? Okay, so in the following way, we can detect how many rows are not complete. Yeah, if that's the case, then we can just use the values of the complete cases and to remove those data. Okay, remains the data, and we can just use complete cases. And complete cases will in this case will keep all rows with the value of true in our data. Okay, so let's see what we got here. And now you can see RM data. Okay, so now RM data, we only have 88 observations with 5 variables. Okay, so this data set is complete data case. That means we don't have any NA values in there. So that means it's clean already. Okay, so that's what we got here. But this is not a good way. If you want to keep all information in our data set. So if that's the case, we can use a second approach. You can use mean, okay, or first quartile value to fill the missing values. Okay, so this is how we did here. We are gonna use mean value. So the mean value here, okay, so first of all, let's specify the data to be mean data. And then we will try to use mean data. Well, this mean data is column number 1. Okay, we are calculating the mean value for column 1. Okay, so what's the column 1 data? Let's see. Okay, we got the sample length here, right? This is column 1. And then followed by NA.RN. NA.RN means NA remove. If we set NA.RN to be true, then we can calculate the mean value, because if you ignore this, it will return error because we cannot get the mean value of NA values in our data. So if there is a NA value in our data, we cannot do any calculation because NA is NA, right? Even we want to do some calculation, yeah, we can't get an answer about that. So we have to specify NA value to be removed, to be true. Yeah, if that's the case, then we calculate the mean value. And then yeah, that's the mean value 1. Let's see what we got here. Okay, the mean value is 5.83. Okay. And we can replace the NA values in there. Okay, so now we have to specify how many rows having NA values. So let's see. For the first column, we have, yeah, this is for the first column. and this just specify the number of rows having NA values. Okay, so now we're gonna replace the NA values in the specified rows with our min values. Okay, so that's one way to do that. Okay, so that'll be done. Yeah, of course, we only cover the first column in our data, and you still have to finish the rest of columns by feeding an adequate values for the missing values. So it probably will take a lot of time to do that. Okay. Okay, so then we come to the third approach, which is the most popular one. We call this as k nearest neighbors. Basically, this is based on the statistics. Yeah, we will try to find the nearest neighbors, and we'll choose the mean values from the nearest neighbors. Okay, so basically they're using this approach. So we don't need to go into details about this approach, but basically you can just use the package we call DNWR. Okay, we just load up this package, and then we can use KNN imputation, so that will be faster. So let's do what we have here. Okay, so let's see what we got here. We got the impute data here. Okay, so this is imputed data, and let's see. Okay, so this is our NA values data with NA values. Okay, so for example, like rows number 7. Okay, we have NA values in separate length. So let's see what we have here. Number 7, row number 7, we got the imputed values, which is 5.08. So this is imputed values. Okay, this is the original data. Okay, so what about the row number 10? Yeah, we got two NA values here. One is petal width, another is species. So let's see what we have here. Okay, row number 10, right? Row number 10, we got here. Okay, so we got the petal width, which is very close to 0.2, and species is Setosa. Okay, so very close to 0.20. Okay, obviously the result is pretty reasonable. Yeah, we can just use this approach to do that. Okay, so that's about the imputed value. Okay, the last approach is to use the mice package. Okay, but it probably will take much longer to do that because it would, of course, it use more sophisticated statistic approach, but we also don't have to dig into this approach right now. But you can just try, but this probably will take much longer because it is using using a lot of memory. So maybe we can try to see. Yeah, now you can see it's been running with some statistical methods we call resampling approach. Okay, so probably it will take much longer. Okay, it's been finished, but because our data set is pretty small in size, so it won't take too much time. but basically we'll create 3 tables. The first, the 1, 2, 3. Yeah, you can use either one of them. You can use any one of them. Yeah, 1, 2, or 3. Let's take a look at the first one. Yeah, so that's the complete data set. Okay, so let's see what we have here. Remember row number 10, we got some missing values in there. So now you can see the obtained data is 0.2 and the species is Setosa. And the row number 4, I think the first one is missing value here. Okay. Yeah, so you can see those numbers are reasonably estimated and viewed altogether, so no problem about that. Okay, so probably that's the end of this piece of code. We have cover R01_7. Yeah, this piece of code covers some issues in data processing. Okay, so maybe we can take a break. It's okay. If you have questions, you can text me or other professors, CP Chang. Yeah, okay, so let's take a break. Yeah, I've seen questions from Lulu saying that the data has different locations, and yeah, that's because the data is the NA values are generated randomly. So basically, my NA values, the location my NA values are different from yours. Maybe we can try to fix it. Think about it. Yeah, just give me a minute. So let's take a break first, and then we'll come to this issue later.